And she's okay. That is from child. Okay. Nice to see that we have a global audience. Okay. Yeah. So yeah, thank you so much, guys, for coming over for this lovely session on introduction to data science and data analysis by Mr. Shubham Mittal. So I would like to talk about Mr. Shubham Mittal, guys. So Mr. Shubham Mittal is currently working as a senior ML engineer at Renault Payment. He holds a master degree and he has over 4 years experience. Yeah. So Mr. Shubham has also worked on hundreds of projects for multiple like AI domains such as machine learning, deep learning, natural language processing, and computer vision. So yeah, guys. So there are tons of things that you can learn from Shubham, and he'll be helping us today with our session. So it's gonna be a fun session, guys. So I see we have around 76 participants. So we'll wait a minute or so for more participants to join in. Meanwhile, I would like to mention, guys, that we are also live on our YouTube channel. Okay. Yeah, and we have quite a few participants joining in from there as well. So yeah. Also, guys, the PPT which our instructor is going to use and the session recording, both the things will be available to you on your Eduonix dashboard by next 24 to 48 hours. So those who are joining in late, no need to worry about the session recording as well as the PPT. So yeah, I see we have around 84 participants. And as we are waiting for more participants to join in, I have a very good news to share with you all. And that is Eduonix, guys, is coming up with some really cool offer during this session. And this offer is to help you gain more knowledge in the field of data science and data analysis. And those who want to learn more in this field, so yeah, it's gonna be a really cool offer for you all, guys. And I will reveal this offer at the end of the session. So I would request you all to please stay with us till the end of this session to know what the offer is, guys. Yeah, nice to see we have almost 90 participants now. Yeah. So I guess now, like without taking much of your time, uh, Shubham, if you are there, then we can just take forward this session.
Yes, yes. Am
Yeah.
I audible?
Yeah, Shubham, you're audible. Welcome. And yeah, you can take this session forward from here. I will just stop the screen sharing.
Thank you. Thank you so much, Vaibhav.
You're welcome.
A very good evening to all of you. My name is Shubham Mittal, and I've been working in the space of artificial intelligence and machine learning for past around 4 years. And as far as my academic background is concerned, so I have completed my master's in artificial intelligence and machine learning from NIT Warangal with a GPA of 3.67. And I have made various projects based on machine learning, deep learning, natural language processing, computer vision. So these are my areas of interest, and these are the areas that I'm currently working on. So this is about my background. So let's start the topic. So I'll share my screen. Uh, are you guys able to see my screen? Yes. See. Okay, so let's start with the topic. The topic is Introduction to Data Science and Data Analysis. Okay, Introduction to data science and data analysis. So let's first of all discuss what exactly is data science and what exactly is data analysis. So these are like buzzing words today. Data science. Everyone is hearing data science, data science. So let's try and understand what exactly is data science. See, data science is all about solving a problem. So let's first of all start with the problem. You can take any problem. For example, we have a classification problem that we have to find out whether any transaction that is being processed is a fraud one or a non-fraud one. Okay, so we have to find out whether a transaction is a fraud one or a non-fraud one. So it's a problem. For example, we have to find out whether this image is a cat or a dog. Again, it's a problem. Okay, it's a problem. So we have to first of all take a problem. Now, for example, there are 10,000 students in a school, and we have got the data of height of each and every student present in the school. And on the basis of that particular data set, we have to identify that this height is considered as an average height, this height is considered as an above average height, and this is below average height. So again, this is a problem. So data science and data analysis is all about solving a problem. So that's my first step. Okay, it's all about solving a problem. Now, now to solve a problem, what exactly is the first thing that we need? See, if I say I have to find out for 10,000 students what exactly is the average height and what exactly is the above average height and what exactly is the below average height. It's a very basic problem. I'm not going to get into any of the algorithms, any of the other things, any of the complex things. I'm just taking into the account basic things, very basic things. So see there are 10,000 students in a college, and I have to find out the height of this particular student is considered to be an average height or below average height or above average height. So to solve this problem, what do we need? We need data first. Okay, the very first thing that we require is data. So we need to have data of all the students that is present in the school. Yes. Similarly, to solve any problem that is there in data science, that is there in any domain, we need data. Okay, so that's the reason why here it is mentioned data analysis. Now, what exactly is data analysis? Now, see, we have got the data. We have got the data of 10,000 students. We have got data of height of 10,000 students. Now, just assume this thing that you have an Excel sheet where height of each and every student is being mentioned over there. Okay, there is an Excel sheet where the height is mentioned like this. We have got students and first student, second student, third student, so on till 10,000 students. And heights are being mentioned 170 centimeter, 171, 179, 195 centimeters. So these are the heights that is being mentioned. Now, if you look at this data, you'll not be able to make analysis on the data set after just looking at this data set. Okay, you're just simply looking at some random 10,000 numbers. Okay, now to understand those numbers, to make a meaning out of these numbers, what do we need? To make a meaning out of these numbers, what do we need? We need the very first part that we are going to discuss. See, in this topic, we have divided this topic into 4 parts. The first part is basics of statistics. Second is working with Jupyter Notebook. We'll discuss this in brief. Probability in machine learning and data science and machine learning use cases. So Statistics, the very first part, statistics. So statistics is being used to understand the data, how the data is behaving. Okay, because to make a meaning out of those 10,000 data points, we need statistics. Okay, so we need statistics for that. Now let's understand what exactly statistics. You must have heard of you must have definitely heard of descriptive statistics, inferential statistics. The statistics has got two parts. One is descriptive statistics and second is inferential statistics. Today we are going to cover only descriptive statistics because that's the basics of statistics. Okay, that comes under the basics of statistics. So let's try and understand what exactly is descriptive statistics. See, descriptive statistics, in simple language, if I have to say what exactly is descriptive statistics is a measure with which we try and understand the data better. Okay, and the different measures that we use in descriptive statistics are, as you can see here, mean, median, mode, standard deviation, variance, okay, skewness, kurtosis. So these are the different measures that we use in order to understand the data better. Okay, so this is the this is the thing. This is what we call it as descriptive statistics. Now see how descriptive statistics helps us in understanding the data better. Okay, I'll give you an example. But first of all, let's understand the very basic things in descriptive statistics, that is mean, median, and mode. So mean is basically the arithmetic mean. Mean is also known as arithmetic mean, and arithmetic mean is the sum of all observations divided by number of observations. Okay, the formula for arithmetic mean is sum of observations divided by number of observations. Uh, C, mean, sum of observations upon number of observations. For example, we have got four values, 10, 20, 30, and 40. If we have to find out the mean of these four values, we have to add all these numbers. If you add all these numbers, 10, 20, 30, and 40, it comes out to be 100. 100 divided by 4, it comes out to be 25. Okay, so 25 is the arithmetic mean of these four numbers. Okay, 25 is the arithmetic mean. Or in other language, we call it as, see, what exactly is the deviation distance between 25 and 20 plus 5, 25 and 10 plus 15, it's minus 5, it's minus 15. If you add all these distances, it comes out to be 0, and these distances are being termed as deviations. Okay, so arithmetic mean is also known as a point where my sum of deviations comes out to be 0. Okay, this is also a point. Now what exactly is mean, and with the help of mean, how do we understand the data? Okay, so to understand this thing, we need to understand median first. What exactly is median? I'll show you the slide for median and then we'll get back to this thing again. Okay, so median, what exactly is a median? So the value of the middlemost observation obtained after arranging the data in ascending order is called the median of the data. For example, as you can see the data here, if you can see the data here in the second point, 4, 4, 6, 3, 2. So first of all, you have to arrange the data in ascending order. After arranging the data in the ascending order, you need to find out the middle value, middlemost observation. And the middlemost observation here is a 4, third one. Okay, third one. So median of this observation, sorry, this data is 4. Okay, median of this data is 4. For example, if there are two middle values, then what will happen? See, if I arrange the values to be like this. Now, as you can see here, there are how many observations are there? I can see there are a total of 6 observations. If there are a total of 6 observations, then this means 4 and 6 both are middlemost values. 4 and 6 both are middlemost observations. So in order to find the median, when there are two middle values, we have to find out the average of these two values. 4 plus 6 by 2 average, it comes out to be 5. Now let's back to the same question. How do we understand the data? By looking at mean and median. Okay, how do we understand the data? See, these are my observations: 10, 20, 30, and 40. Okay, if these are my observations, then mean is, we have already calculated it to be 25, and median will be again 25. As you can see that here data is uniformly distributed, no? It's 10 and then 20 and then 30 and then 40. Data is uniformly distributed. If data is uniformly distributed, then mean and median are almost the same. But now let's take the second case. Now tell me, what's the mean? What's the mean of this? Again, we have to add. Yes, if I add, so mean comes out to be, just add all these numbers, you'll get 3030 by 5. It comes out to be 606, and will be median will be 10. As you can see that mean and median are very far away from each other. So we can say that data is actually not distributed uniformly. As you can see, the values are very high at the very end. Okay, see, it starts off with very less values at the start, but it ends off with very high values. So data is not uniformly distributed. So what we do is, in a data set with 10,000 points, we look at mean and median. If mean and median are almost close to each other, then we can say that data is almost uniformly distributed. But if there is a distance between mean and median, that means data is actually not uniformly distributed at the last level, so the last of the data points are actually very, very high, or very, or the start of the data points are very, very less. Okay, so this is what we can infer after looking at mean and median both. Okay, so this is how we try and understand the data better, by using these measures, which comes under descriptive statistics. So I'll give you a very good example, that how do we understand the data. There is a college, and college placement says, college placements committee says that average package, okay, average salary offered to the students of this college is 15 lakhs per annum. Okay, you will say that it's a very good college. Yes, you'll say it's a very good college. But when we get into the details, we find that median value comes out to be around 8 lakhs per annum. Now, can I say that it's a very, very good placement? Yes. Now, can I say that the placements of this college is very, very good? No, because the middlemost observation, that is the 50th percentile student, that's the middlemost student, got only 8 lakhs per annum, whereas my average package comes out to be 15 lakhs per annum. And the reason of this difference is because at the very highest level, basically the numbers which are very high are actually very, very higher than 15. Because of those values only, my average value has increased to 15, but my middle value is still 8. So it is really very important to look at mean and median values both in order to understand the data better. Okay, so that's the first part. So this is how we use statistics in order to understand the data better. Okay, so this is the meaning of statistics. The very first part, descriptive statistics, is just used to understand the data better, that what exactly is the data and how exactly is this data behaving. And after understanding the data set, we have to perform analysis on the data set. Okay, the next thing is mode, a value which appears most often in the given data. For example, here, if you look at this data set 2, 3, 4, 4, 6, which observation is the most frequent one? 4. 4 has got the highest frequency, no? So the mode of this data is 4. Okay, so mode is basically the highest frequency, the observation with the highest frequency. Okay, it's called a mode of a data. So again, we try and understand that that how the data is performing, how the data is uh, how the data is behaving. So this is our main agenda behind using statistics, and these measures we use in order to understand the data better. And there are different other measures as well. Obviously, we'll discuss those measures in detail under the section statistics and machine learning. Okay, so 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 this is what statistics is all about. So the very first thing that comes in solving a problem of data science is statistics, because the very first thing that comes in a problem of data science is data. And in order to understand the data, we need statistics. Okay, so with the help of statistics, we try and understand the data, and after trying and understanding the data, we perform analysis on the data set. Okay, and to perform analysis on the data set, what do we need? We need we need something where we can keep on checking each and everything that is present in the data set. What exactly is the mean of this column? What exactly is the mean of this? What exactly is the median of this column? And what exactly is the IQR values? Okay, so all the statistics measures that are there, we can calculate in this. So the second thing that we are going to discuss is working with Jupyter Notebook. So see, what exactly is a Jupyter Notebook? Jupyter Notebook, just try and understand in a very simple language. Jupyter Notebook is there to help you guys in order to understand, in order to perform all the analysis on the data set. So you know statistics, you know each and everything, and you know each and everything that is there in statistics. You know what exactly is data, but how are you going to calculate the mean of 10,000 values? How are you going to calculate the median for 10,000 values? Obviously, you're not going to calculate it manually. You need something, you need some software or some some application in order to calculate that for you, so that you can understand the data. Plus, one more thing where Jupyter Notebook actually comes in very handy is visualization. Visualization, like you have to visualize. For example, there is a pie chart. Okay, if you draw a pie chart, See, I'll draw a pie chart. For example, you have to draw, there's a pie chart. Okay. See, the very first thing is, why do we draw a pie chart? What exactly is the reason behind drawing a pie chart? There's a company manufactures 5 products, A, B, C, D, E. A constitutes 20% of the total products manufactured by a company. B constitutes 30%. C constitutes 25%. D constitutes 15%, and E constitutes 10%. Okay, now we have to draw these in a pie chart. Okay, let's draw these things in a pie chart. So first of all, we'll have to convert this into degrees so that we can draw a pie chart. Okay, so this is 36 degrees, 54 degrees. The relationship between percentage and degree is 5% is equivalent to 18 degrees. And 25% is 90 degrees. 30% is 108 degrees, and this is 72 degrees. Okay, so we'll first of all draw 90 degrees. This is C. Okay. 72 degrees, B, D, and E. Okay. 10%, 15%, A is 20%, B is 30%, and C is 25%. Now, just look at this pie chart. Just look at this pie chart and try and ask yourself that what exactly, why do we draw a pie chart? What exactly is the reason behind drawing a pie chart? The reason behind drawing a pie chart is you have to understand the data. Suppose you are representing, okay, you are presenting a document, you're presenting any presentation, okay, you'll be using a pie chart, you'll be using any other visualization thing, whether it's a table chart, yes, line graph, or a pie chart, or some other graph. Why do we use it? Because it makes us try to understand the data better for other person. Okay, because after looking at this pie chart, we can easily understand the data. So all these visualizations are for us only to understand the data. Okay, and how do we draw these visualizations? With the help of Jupyter Notebook. So this is where Jupyter Notebook comes in very handy to draw these visualizations. Okay, we can calculate all the mathematical terms, percentile, quantile, all these things. Okay, we'll definitely discuss these things in detail. Now, the next part that comes, in the problem of data science is prediction. Now, see, you have the data, you have understood the data now, you know each and everything about the data. And after understanding the data, you have performed analysis on the data set as well. You have drawn all the visualizations, you have calculated mean, median, mode, you have done feature engineering, you understood what all features are important, what all features are not important. So you know each and everything about the data set. Now, the last thing and the most important thing comes is the prediction. See, what exactly is probability? Probability is a chance of occurrence of an event. If I say, what is the probability that our class, that this session will be live after 1 hour? You know, its probability is 0, because you know that this session is for 1 hour and we are already through half an hour. Yes. So if I ask you, what is the probability that it will rain today or tonight? What exactly is the probability? Again, there are some chances, no? Yes. It depends on the weather. It depends on the historical data. Okay. If I toss a coin, what exactly is the probability of getting a head? There is a chance. Yes. So probability is all about prediction. It's prediction. So how do we use prediction in machine learning is, see, after performing analysis on the data set, now what we need to do is we have to predict that with this X, what will be the value of Y? Okay. For example, we are solving a problem that whether this transaction is a fraud one or a non-fraud one, or whether this image is a cat or a dog. For this image to be a cat, if we get our probability to be 0.8, that means my algorithm is saying that with 0.8 probability that this image is a cat, and with 0.2 probability that this image is a dog. So what will you do? You'll classify this image to be a cat. Okay. So at the very last level, when we are at the prediction level, when we are predicting the outcome, at that point of time, we require probability. Okay. So this is the reason why probability is actually very important in machine learning. And to understand the probability is also important. So let's try and understand what exactly is probability. See, probability from the face of it looks very easy. See, just try and understand. I'll ask a very simple question. See, if I toss a coin, as you can see the formula, probability here is favorable outcomes upon total outcomes, no? Yes, and total probability is always one. See, if I toss a coin, what will happen? It will either be a head or a tail. Yes, the outcome will either be a head or a tail. So how many outcomes are there? Two. What is the probability? What is the probability of getting a head? What exactly is the probability of getting a head? Yes, it's 1 by 2. Yes, yes, it's 1 by 2. Yes, and probability of getting a tail is also 1 by 2. Yes, so I can say that that both head and tail have got equal chances. Yes, both head and tail have got equal chances. Yes, both head and tail got equal chances. Yes. Now, if both head and tail have got equal chances, now let me ask another question then. Another question. So, if this is the case, then I can say that, no, if I toss my coin 10 times, if I toss my coin 10 times, then 5 times it will show us heads and 5 times it will show us tails. Will this happen? Yes or no? Ashish is saying yes. Praveen can't say why. AK maybe yes or no. See, we have already discussed that both have got equal chances. Both have got equal chances. Both the outcomes have got equal chances, a head or a tail. Okay. Yes, the coin is flawed. Okay, Biju, is coin really flawed? And how do we decide that this coin is flawed and this coin is not a flawed one? If I toss a coin 10 times, if I get 5 times head, 5 times tail, then that coin is not flawed. Otherwise, each and every other coin is flawed. Akshar, the question is, if I toss a coin 10 times, then it has to be 5 heads and 5 tails. Is it really? Because we have already discussed this that both head and tail have got equal chances. Yes, Praveen is a random function. Every toss is unique in itself. Yes, okay. Okay, so let's try and understand with a different example. Let's try and understand this thing with a different example. See, if I ask you, what is the probability that it will rain tomorrow? Whether it will rain or not rain. So there are two outcomes. So probability of rain has to be 1 by 2, no? Yes or no? Yes. Okay. But if you Google it that what's the weather today, so you'll see chance of rain. So that chance of rain should always be 50%, no? But there, it's written 80%, somewhere it's written 90%, somewhere on some other day it is written 10%. Why? Why then? It depends on weather. Okay. Okay, so I'll tell you this thing. So there are two probabilities. One is a random probability. Other is a probability based on historical data. Now, see, in India, in the month of July, it's it's a month of monsoon. Yes, in India, in the month of July, it's a month of monsoon. So there are very high chances that it will rain. There are very high chances. So probability of rain will definitely increase in this month. Yes. But in the month of December or January, probability of rain is very, very less. Okay. And I'm saying this on the basis of historical data. Okay. So I can say that when we have got historical data with us, okay, the experiment is not a random one. Okay. The experiment that we're trying is not a random one. This is the reason why probability is not half when we say that what exactly is the probability of a rain. Probability is not half. Now, I'll ask another question. This will clear each and everything. Yes. See, you know historical data. Yes, Praveen. Yeah, historical data plus present conditions as well. We take all these things into account and we keep on forecasting our weather, and this is how we calculate the probability of a rain. Now, just assume one very hypothetical situation that you are an astronaut and you have just landed into a new planet, a very new planet. You don't know anything about that planet. Okay, you just landed into that planet. Now, you don't even know that will there be rain on that planet or not. You don't know. So, on that particular planet, what will be the probability of rain? You do not know anything about that planet. Yes, Praveen, it's zero point 0.5. It has to be half now because it's random now. It's a random thing now. You don't understand. You don't know anything about that planet. So whether it will rain or not rain, it has to be half. Okay. Yes, exactly. Yes, it's zero point 0.5. So whenever we toss a coin, a single coin, we do not know anything about that coin. This is the reason why that experiment is known as a random experiment. Whereas whenever we try to calculate the probability of rain, we have got historical data with us. And on the basis of that historical data, we can say that probability of rain is not half. Whereas for one single coin, where we do not know anything about the historical data of that particular coin, it's a random experiment, so it is zero point 0.5 or 1 by 2. Am I clear on this? Yes. What exactly is a random experiment? Okay. So this is probability. So this is what I've explained. This is all written here. Okay. And total probability is always one. If I say probability of rain plus probability of no rain, it has to be one always, because it will either rain or not rain. So it's 100% case. Yes, so it is one. Okay. Now, see, where do we use probability? As you can read in the slide, these concepts have been given an axiomatic mathematical formalization in probability theory. Okay, which is used widely in the areas of study such as statistics. So we use probability in statistics. Okay, mathematics, science, finance, gambling, artificial intelligence, machine learning. We are more interested in artificial intelligence, machine learning, computer science, game theory, and philosophy. Okay, so in all those areas where we are trying to predict anything, probability comes into picture. For example, let's take gambling. In gambling, and we are trying to predict whether this team is going to win or not. So on the basis of, see, again, it's not a random experiment. We know we have got historical data behind. We have got historical data with us, no? On the basis of that historical data, we can actually predict with the probability that will this thing happen or not. For example, Olympics are going on. If I have to predict that which country will get the most number of goals, I cannot say any random country. Yes, because all those countries have got equal chances. No, all these countries have not got equal chances. On the basis of historical data, we say that the probability of getting most number of goals which for China and USA is very high. And after looking at the present conditions, we can say that Japan is also looking very, very good to get that thing. Okay, so so this is how we use probability in machine learning. Okay, we try and predict. Okay, so we have discussed this. So whenever we roll a die, okay, whenever we roll a die, there are 6 outcomes. No, 1, 2, 3, 4, 5, 6. There are 6 outcomes. Again, it's a random experiment. Okay, so again, it's an equal probability for all those outcomes, 1, 2, 3, 4, 5, 6. Okay, so that experiment is random. So whenever we do not have any historical data with us, that experiment is considered to be a random experiment. Otherwise, experiment with an historical data. Sorry, experiment with the historical data. Now, the most important thing, that why there is a need to learn data science and machine learning. So let's look at the applications. Okay, where we are currently using data science and machine learning. And when I say machine learning, artificial intelligence, deep learning, everything comes under that. Actually, under artificial intelligence comes machine learning, and then under machine learning comes deep learning. But machine learning is actually quite famous these days, so I have written machine learning. Okay. So the very first point is classification algorithms. So as we have discussed, classification algorithms are like predicting one outcome. So whenever we have got two classes, for example, we have to predict whether this transaction is a fraud one or a non-fraud one. So there are two classes. Okay, whether this image is a cat or a dog or some other elephant. There are classes. So in order to solve these kind of problems, we use classification algorithms. And these classification algorithms are there in machine learning in order to classify, okay, in order to classify the images, in order to classify the values. Now, the second thing is regression algorithms. For example, we have to predict the price of the house on the basis of different factors. Okay, on the basis of different factors, uh, like uh, uh, like the length and the breadth. Okay, square yards of a house. On the basis of these different factors, we have to predict the price of the house. And price of the house is actually not a class, it's actually a number. So whenever we try to predict a number, we use regression algorithms. Okay, and the third one is reinforcement learning. Reinforcement learning is actually very, very interesting. It's actually very interesting. In reinforcement learning, we do not require data. So basically, for example, computer. So what computer does is computer tries to understand your behavior after looking at your behavior, and then try to replicate that behavior. And after a point of time, it tries to overpower you. For example, you are very good at playing Call of Duty. Call of Duty is a very famous game. You are very good in playing Call of Duty. So computer tries to learn from you. First of all, computer does not have any access to the data, so basically try to learn from you that how you are going to play, how you play the game. And after learning from you, it keeps on practicing that game by using different features and try to beat you in that particular game. So this is what reinforcement learning is all about. Text to speech, speech to text. So you guys must be using WhatsApp and all these things. So you can easily Facebook, you can easily convert your text to speech and speech to text, language translation, okay, recommendation engines. So almost all of the almost all of the shopping websites are using recommendation engine, that your personalization thing. For example, you're more interested in gaming, so they will show you products related to gaming. If you are more interested in technology, so they'll show you products related to technology only. Dynamic pricing, for example, in hotel industry, so they'll follow this approach of dynamic pricing, so that they can increase their revenue, they can increase the profit. So, so the pricing of that hotel room will keep on changing depending upon the season automatically. So you do not have to decide the price. A function or a machine learning algorithm will decide it for itself how to maximize the overall profit at this point of season. Okay, so it will decide the price. And image processing is just look at the image and try to understand what exactly is there in the image. And there are different things that we can do with image processing. And the very basic example is, we have to identify whether this image is a cat or a dog, whether this image is an elephant or a lion. So for example, this Facebook does is tries to predict that, and in this image, this person is named this person is named this. Okay, so these are the different applications of data science and machine learning. So the next is Q&A session. If anyone has got any question regarding this, okay, regarding all these 4 points that we have discussed, you may ask. I'll open the chat box. Since a movie is made up of, since a movie is made of images, is it possible for machine to predict that the movie is going to be a blockbuster? Right. See, obviously, we can, with the help of machine learning, we can predict whether the movie is going to be a blockbuster or not. But right now, with the current thing that we have, with the current system that we have, I don't think that we can solve this problem with a much greater accuracy. Okay, there is obviously this accuracy thing. For example, see, obviously we can train our model on blockbuster movies or non-blockbuster movies or flop movies. Okay, we can train our model on that. But with the current system that we have, we can solve this problem. That's not an issue. But the accuracy is a problem here. What are the difference between data scientist and data analyst? So the major difference between data scientist and data analyst is, so data scientist solves the problem, data analyst only analyze the data. Data scientist solves the problem from the starting to the very end, that is gathering the data first, second part is cleaning the data, third part is understanding the data, fourth part is analysis of the data set. After that, performing algorithms on the data set. And after performing algorithms on the data set, check for accuracy. And after checking for the accuracy, put into the production mode. So these are the things that a data scientist does. But data analyst only performs analysis on the data set. Can we use a video of a street and map the various features in the frame onto a digital map? So this problem looks a different one. This is like, video of a street and map the various features in the frame onto a digital map. Yes, you can do that. It's like I guess you're talking about this problem, no? That Google Glass, that you're wearing a glass, and that glass will tell you while walking on a street that this place is this and this place is this. For example, you want to have a pizza, so it will show you the places on that Google Glass that this place will serve you a pizza or not. So I guess that is easily achievable. In image processing, which kind of statistics concepts are used? Does its analysis insight focus on pixels that constitute the image? Actually, as far as the statistics thing is concerned, Shreya, so yeah, as he rightly said, that it actually focuses on the pixels that constitute the image, and pixels are nothing but numbers. Okay, pixels are nothing but numbers, RGB 0 to 255. So we try and analyze those numbers. So it's more of, see, in image processing, we generally use deep learning concepts. And in deep learning, we just feed on the data set. We do not perform any statistics on that. Statistics comes under only machine learning. Obviously, we do some statistics in we do we do use some statistics in deep learning. For example, normalization, dropout techniques. So these are the techniques that we use. But but we generally use more of a statistics in machine learning problems. So if we have millions of data, can you just use few thousand of data points for data? Yes, exactly. But the thing with see, you have to see millions of data is being known as population, and thousands of data is known as sample space. So sample space, you have to choose a sample space which actually represents your data first. Basically you have to perform statistics on the data set, and you have to take out that particular data set which have got the same statistics as the population. Then you can perform visualization on that data set. You're welcome. If an accuracy of a data set turns out to be 50%, then can we trust and give a go? See, if we're getting an accuracy to be very low, see, for example, there are two outcomes, one and two. Okay, if I classify each and every outcome to be one, my probability would still be 50% now. My probability would still be 50%. So 50% probability is definitely a problem. But again, it depends on the problem whether an accuracy of 99% is bad or an accuracy of 75% is also good. It totally depends on the problem. For example, if you are looking at a problem of credit card fraud management, see, most of the transactions are non-fraud. If you look at the transactions, most of the transactions are non-fraud. So 99.99% of the transactions are non-fraud. So if I classify each and every transaction to be non-fraud, I'll get my accuracy to be 99.9%. But this accuracy does not make any sense. Okay, so it totally depends on the data set whether the accuracy of 99.9% is bad or accuracy of 80% is considered to be good. Okay. Uh, is mathematics students choose data science as career? Yes, yes, definitely. Yes. Yes. So in algorithms and in the starting algorithms, we use mathematics to understand how algorithms are behaving. And no, it's not tough. It is definitely not tough. Yeah, deep learning thing, natural language processing thing is tough, but at the very start, it's not tough. Hmm. See, an image, how to convert an image to numbers, can you give a Python function? See, whenever we take an image, whenever we take an image, we convert it into pixels. We have got pixels values to it. Okay. Otherwise, we'll not be able to understand. And And in order to analysis on any image, we use a library named OpenCV. Okay, so let's talk about the product. Okay, so let's talk about the product. So why it is important uh, uh, to go for this live online training on data analysis and with Python. Okay, so instructor led 2-day live session. Okay, so there will be session on 2 days, and 4 hours of live training will be there, and it is like totally self-paced. Okay, and it is time bound. Okay, and as you can see, we have got live question and answering sessions, so you can ask almost each and everything whatever you want to. Okay, and portfolio oriented projects, latest and trending tools we are going to use. Okay, portfolio oriented projects, that is project related to your portfolio. Will be covering each and every project, real time interaction. Okay, and there will be quizzes and MCQs as well, and you'll be getting a certification for sure, and which is definitely industry verified. Okay, and these are the things that we'll be covering. These are the things that we'll be covering in this course of data analysis with Python. So the very first thing that we'll be covering is data analysis with Python and what are the popular data science tools that we use, data mining, that how do we gather data. Okay, and after gathering the data filtering and distribution, data cleaning and transformation, that how do we prepare data in order to put that data into training. Okay, data visualization and interpretation, as we have discussed, that how do we visualize our data set, what are the different libraries to visualize our data set, and data analysis of traffic violation data set. We'll be performing all the analysis on one particular data set, and will be also preparing for interview questions for pandas. Okay, and you'll be building industry project, like analyzing traffic violation data set. On one particular data set, we'll be doing multiple things. We'll be analyzing the whole data set. And this is the offer that we were talking about at the very start. uh, Weber, if you can take over now.
Yeah,
Yeah.
hi Shubham.
Yes.
So yeah, uh, s- I will just quickly take over the screen. Okay, just let me know whether my screen is visible or not. So okay. So first of all, it was lovely to hear you and to understand the concepts of data science and how the probability and all works. It was really fascinating for me as well. So thank you so much for that, Shubham. And as I was talking about the offer at the earlier at the start of this session, so I thought I would share it on, like I'll share my screen and I'll share few the key points. As our instructor, Mr. Shubham has already told you guys that why you should go for this course. So at Eduonix, guys, we have our own e-degree, which is going to be live sessions. So we are coming up with this, and this e-degree is known as data analysis with Python. And this course, guys, is specially curated for you all. And I hope, and I have seen the responses in the chat box that many of you are interested in machine learning and to gain knowledge in this data science topic. So yeah, guys, so these are the few key points which our instructor also told, and as you can see on my screen as well. So we'll be giving out like latest and trending tools, like we are working on latest and trending tools. There will be an interactive quizzes and MCQs, and I'm sure that these quizzes will really help you during your interview, or your when you will enter in the industry. Will be also from the industry. I'll just mention this point that we are giving out the certification, like on the completion of the course we'll be giving out the certification, and these certificates will be industry accepted, uh, so no need to worry about it. So this guys workshop will be of 4 hours, so 2 hours each day, like, so it's gonna be really fun. So what all things you're gonna learn from this e-degree, guys? So as you can see, like data analysis with Python, popular data science tools, data mining. So these all things. Also, we'll be doing the projects which is industry based, which will help you to gain the practical knowledge, and to help you like know how the things really works. So yeah, as our this is our offer, guys. We'll be giving out this e-degree for flat $15. It was actually for like $50, then 19. So but for the next 24 hours, guys, this offer is only valid for next 24 hours, and we will be giving out this e-degree at flat $15. So I'll just quickly paste the link in the chat box, guys. Do let me know whether the offer link is working. And yeah, just give me a second, guys. I'll just copy paste the link. Yeah, so here is the link. So guys, let me know this link is working or not. Yeah. Also, guys, I'll be sharing one another link. It will be a feedback form link, and we would love to know your thoughts on how did we performed, and your feedback is really valuable to us, and it actually helps us to make our upcoming sessions more interesting, more fun. So please feel that feedback link as well. Also, guys, I would like to mention that this feedback link as well as the offer link, both the things will be sent out to you on your registered email. So those who have missed the link, no need to worry about it. We'll be sending out the offer link as well as the feedback link. Okay. So yeah, guys. So by saying that, thank you so much, Shubham, for this lovely session, and thank you all for attending this session and to be with us. Uh, yeah. So yeah, guys. So we'll wrap up this session over here. And thank you so much. I will again for the last time. I will paste the link over here. So yeah, thank you so much, guys.
Okay.
Have a
Thank
great
you.
day. Thank you, Shubham. Thank you so much.